Hi again to all audience. We have with us Mr. Pramod right now. Mr. Pramod will talk to us about open source cloud native. To give you a brief introduction about him, he brings with him 19 years of experience in cloud architectures, system design and development and network domain. He currently heads the technology development team at Tata Communications Limited, a global leader in network and cloud service providers. He is responsible for building the next generation ISPS infrastructure at Tata Communications. He holds multiple patents in the area of Unix system architecture and virtualization. Prior to joining Tata Communication, he was with IBM for 9+ years as advisory software engineer. Between that period, he also had a stint with e-commerce startup as a founder and CTO. I handed the stage to you, Pramod. Looking forward to hear.
Sure. Thanks, Animika. Hey, everyone. I'm sure you've had an interesting day so far. So today, so I'm going to talk to you about, cloud native applications and why, cloud native matters. Why should every developer and every organization move to a cloud native world? So we will briefly talk about, how the world has evolved, right? How the landscape has changed from a monolithic application architecture towards cloud native, and why is it happening? Right? What are the benefits of a real cloud native architecture, right? And what basically why we should do that. So let me share my screen. That's possible, right, Anamika? Yeah.
Yes, it is possible.
All right. All right. Just give me a second. Just give me a second. Okay. Can you see my screen?
Yeah.
All right. Okay. So we are going to talk about, as I said earlier, the changing landscape for software applications. Why are they changing? And then we'll talk about, what was earlier, right? The need for change, right? What are monolithic applications, right? How do they differ to microservices? Microservices is the key ingredient, if you might say so, for building a true cloud native application. And then we'll delve deep into what exactly is cloud native and what it brings to the table, right? So if you see, if you ask any developer who's been around in the industry for a few years, they would have seen this transformation across these three pillars, which is the infrastructure layer. Then there is the IT process, and then there's an application, right? So it is changing across. Initially, when I started my career at IBM, so we used to have this big development cycles, right? Say, let's say if it is 2020, we will say in 2021 fall we will have these 10 different features which will come, and then there used to be a big release, a big fat release where the customers would have to take a big downtime, then upgrade to that release, right? So, and all of this was hosted at the customer premises, right? It was all co-located inside the premises, and it took time because we used to follow this big waterfall development model, which is, we spend time capturing the requirements, we deliberated across different teams, prioritization of what those, then once the requirements are created, we used to get into a big design phase, right? That used to take the bulk of the time, and then there was a coding phase, then there was a functional test, then there was a regression test, then there was a performance test, right? After all of this, the release would happen, right, once a year typically, right, or maybe more than that. So this is what a monolithic app used to be. And then as the cloud proliferation started, I would say we are still present in this middle layer, where we are not entirely towards the microservices or a cloud native stage. There are still a lot of applications which are running in a hybrid model, so to say, where although there are no legacy huge fat apps, uh, you know uh, there are still quite bulky applications all bundled together as a single binary. But the change is, some of the applications are moved to a cloud. They're being made cloud enabled, so to say, right? Not a cloud native, but still the same the same code now runs on part of it runs on a cloud, part of it runs on managed hosting cloud, or on-prem cloud. And they move towards an agile methodology. So agile methodology is something where you don't go into a year-long or a 6-month-long development cycle. You break down those features into a user story, where each story provides a specific feature. So and then developers work on that user story. They develop a certain feature, and then the release cadence is shortened, where you instead of doing 6 months, you do a monthly release. But on the application itself, let's say there are still, instead of one big monolithic, there are multiple tiers, where you have a DB tier, you have a middleware tier, you have an application layer. But the still application layer is still one big binary. Then there's a middleware where all the features are stuffed together. Then there is a infrastructure layer. So this is where we are at. But a lot of these startups, the new age startups, have moved towards a fully a cloud native infrastructure, where everything is decoupled, right? Every feature is decoupled. They run as separate services, which are coined as microservices, right? And then the whole process, the IT process, has changed to a DevOps, which is like a continuous integration, continuous deployment model, where the line between a support team and an ops team and the development team is is very gray, right? So a developer, let's say, checks in code and it goes into a Git repo. The whole cycle of build, testing, deployment to an UAT and deployment to a production is automated. There's no intervention required by any of those. And because of this, they are able to achieve this agility, where new features can be deployed. And then DevOps also, they are able to do a canary deployment or a blue-green deployment, where a new change gets deployed only in certain regions to a certain set of users. It is tested there, right? It allows you to fail fast, recover fast, and then make changes fast, thereby improving your customer experience and all of that, right? So this is the way where all the not only the startups but the enterprises are also headed towards. And this is where our session today will be focused on. How do you move towards a microservice architecture? What are the key components there, and what benefits would one see when they move towards that, right? So one data trend here is that by 2021, 80% of the application development will happen with microservices and cloud functions, right? And then 95% of new microservices deployed would be on containers. Okay. So what exactly is a monolithic app? So we briefly discussed that in the previous slide. So it is built as a single and indivisible unit, right? It just gets shipped as a, let's say if you're a Java developer, it gets shipped as a one big war file, and at the code base, there's one large code base. It is not modularized, right? As and when you grow, it scales. It becomes very hard to understand because you don't know what modules, what the code interacts. If you change here, you don't know the impact, what it breaks, right? And because it is tightly coupled, there are multiple teams which are working, and the collaboration needed for different teams to it becomes a little harder because there are multiple teams. One guy checks out a code, the other guy has to wait for him to fix, and then ensure that whatever new change that the second developer doesn't break the first one. So all of those complexities are involved. And if it is a monolithic architecture, if it is built on Java, most of this thing will be built on Java, right? You don't have the flexibility of using, let's say, a Golang or an R or a Python or something else. So that becomes it doesn't allow you to break the technology barriers. Tomorrow there's a new technology coming up, a shiny new tool where you gives you a lot of these features, but it becomes very difficult for you to adapt that, right? And lastly, it cannot scale. I think it is pretty obvious, right? So let's say you develop this big monolithic application which runs on a VM, right, a virtual machine. And if you see a slowness there, right, and either you'll have to build a larger VM and then deploy this architecture, right? You cannot horizontally scale this, you cannot scale individual components. It becomes so much more complex. And because of those complexities is where people started gravitating towards these microservices applications, where instead of a big monolithic application, you divide each feature as a microservice, right? Every feature as a microservice, and each of those services has its own scope, and they can independently be modified, deployed, scaled, right? For instance, let's say you have a big let's say you have an e-commerce application. So an e-commerce application typically would have your order management system, you'd have your front-end UI, it will have your, let's say a seller portal, right, where the sellers will come and upload their products. Then it will have a image repository, right? So all of these services, instead of bundling them together and deploying as one big, e-com engine, so this could be built as one, let's say, a container for now. And each of these containers, let's say tomorrow there are more and more users coming and hitting your website, that this particular service is trained to resources, so you can scale that independently. You can increase the number of those resources alone without having to scale the entire infrastructure or application, right? So, and it becomes easier to understand, right? So there are people who are working on these microservices, and if something if somebody else has to, they don't have to read through the entire code base. They just have to focus on this microservice, and then they will be able to carry on from there. Scalability we just talked about, right? You can scale these individual components, and it also helps reducing the cost. Flexibility in choosing technology. Let's say tomorrow the one of the services, there's a new language which comes up, right, or a new open source tool which comes up that is, and you want to incorporate that. So you don't have to worry about rest of the ecosystem here, right? For let's say for this microservice, you need that tool. You can easily go ahead and incorporate this, make the changes, right, test it, and then deploy it. So there's no huge cost involved, and there's no technology entry barrier itself. And of course, it increases agility. Each of these microservices can have its own release cycles, can have its own cadence, and as and when there's a feature request available from the business, so you can just make this change and then deploy it, right? It is and because we are saying we're adopting DevOps practices, the whole release cycle gets it becomes very agile. Okay. So this is what cloud native, this is what cloud native means, so to say, right? So we talked about monolithic, we talked about microservices. Just by having microservices, dividing your code into microservices doesn't mean that you've become cloud native. So cloud native, being cloud native is much more than just dividing your monolith application into a small microservices. So what we are saying here is, cloud native is the way to increase the velocity of your business and method to structure your teams to take advantage of automation and scalability that cloud native technologies that Kubernetes offer. So what does it mean, right? So we talked about, so at basically at the why cloud native, it is all, it is just one core principle which or one core requirement which is key here, is it puts customer first, right? What do you mean by customer first? So in this world, the demands on the customer are changing fast, right? They need the businesses are becoming more agile. They need to change pretty fast. They can't wait for. So whenever their business has a need, they would expect that their applications, their software also is as agile as the business needs are. And so you'll have to put the customer first here, and that is exactly the key benefit that being cloud native provides to an organization, where you are very agile, you are lean, right? You're not you're not dependent on the infrastructure being available, right? You are basically, you are, as a developer, we are only focused on our feature, right? The feature and what is that API I'm going to expose, right? I don't have to worry about let's say setting up this whole big infrastructure, interconnecting the machines, and then worrying about what is the storage available, what are the compute resources available, right? And what operating system do I run? Am I compatible? Can I run on this cloud? Can I run on-prem? Can I run, this library? All of those complexities are hidden to a cloud native app. So being cloud native means, it is a software that is loosely coupled, and it is designed in a service oriented architecture with a bounded context, right? So your that software, that piece of software can run on any infrastructure, can scale independently, right? And all the layers, right? All the layers are built as code. Even the infrastructure is built as a code, right? So if you want new storage needs to be added, all you need to do is run a piece of code which scales up your storage. If you want let's say you want to interconnect to services, all you have to do is just make a call, right? If you want let's say your application needs a specialized compute resource such as GPU and all, again, that's just an API call for you. So that is what being cloud native means, right? So this involves the infrastructure as a code. It involves the application divided into microservices, which are scaled, managed, and then operated independently. And then on top of that, there is a continuous integration and continuous delivery pipeline through the DevOps process. So this again is a key ingredient here, where the moment you have the code ready, the whole pipeline is automated, where the code gets built, tested independently, and then it gets delivered continuously, right? So this is like a full cycle. So this is like a small loop batch, right? You have a small feature, you do an individual development, you do a unit testing, and then you deploy it, you check in. So once you check in, this whole cycle repeats, and then it gets deployed. And then if there's a problem, there's a problem, then immediately you roll back, you make the change again, right? And then redeploy it. So So what that gives you is that fail fast mechanism where you get feedback immediately on on the feature you have developed, and then you fix that, and you improve on that. So it gives you this, and that's how you become agile, right? And then so once this is done, so this whole thing becomes fault tolerant, and it becomes easily scalable. Why does it become fault tolerant? Because this microservices runs, the way you package it, it runs independently, and then it can be scaled independently. Typically, when you deploy a service, you specify that I need 3 replicas of it, right? So each service gets deployed in 3 different virtual machines, and then it is load balanced. Let's say if I take a typical Kubernetes environment, there's something called an ingress controller, and this ingress controller manages the availability of these services, right? So even if a microservice crashes due to a bug, or due to some problem, Kubernetes knows, it detects that it fails, and it immediately brings it up. So it becomes like a self-healing an application. So, and then it becomes self-healing. So that's how it is fault tolerant. And then and because you are able to specify the number of replicas you would want, tomorrow you see that the load increases, you can just say that I need more replicas, and then the an engine like Docker orchestration engine like Kubernetes can easily scale that part of it. So all of this would result in a cloud native application. So it could so there are many ways to build a cloud native application, but the trend, or what is predominantly being done today, is through Kubernetes engine. Kubernetes is, as you would know, that it is an orchestration engine for Docker containers. So every container is your one microservice. So you'll have to divide your application into different microservices, and then you use the Kubernetes native features for scale, for fault tolerant, for being fault tolerant. So all of those, it just comes inbuilt with Kubernetes. Okay, so we'll talk about I think we've touched upon most of this, but again, just circling back on the key benefits. So customer first, right? So when we say customer first, we said there's a feature request from a customer. It is, and because we are not worried too much about the other things like infrastructure, like network connectivity, like storage, all of those, the developers focus is on delivering that feature, right? So you get a requirement, all you worry is how do I build this code, and then package it, and then ship it as a container. Then there's a DevOps cycle, which with the reduced release cycle, and then the code gets deployed continuously. So there, so that is the key benefit of a cloud native architecture. It increases the agility and productivity, and because the release cycles are shortened, there is DevOps built in, the code modules are independent, right? They are the infrastructure is also built as a code. The time to market is significantly reduced, right? So there is a feature, and this feature can be deployed to a set of users immediately. So that is how this agility is brought in. So agility not only in terms of features, but agility in terms of adopting new technologies, or moving towards a different moving to a different cloud, different domain. All of this is pretty fast, right? So it's because this is this is cloud native. There's a new feature available in other cloud, and because these are all portable, right? So when we deploy as a container, so one of the key feature of a container is that it is portable, right? So you can move this around to different clouds, different infrastructure domains, all of that, right? And similarly, it increases your productivity. You're not spending too much time worrying about anything other than code. So obviously, code, right? Obviously, there's a huge productivity increase, and also because of the processes, the IT process, what we saw in the first slide, right? Because of those being automated, so we so there is significantly less number of operational activities that need to be taken care. So that is again a productivity, helps increase the productivity, and this all results in a superior customer experience. So we talked about scalability and reliability in an environment like Kubernetes, and also the cloud infrastructure, which is managed in a which is scaled and is fault tolerant. The whole applications becomes that much more scalable and reliable. The ease of management because of decoupling a monolith into a microservices, right? The management also becomes easier. You know where the problem is. You just change that piece of the code, and then fix it independently. Lower costs. I think one of the fundamental reasons why cloud native has picked up is because of open source, right? The rise in open source components like Kubernetes and all of those has significantly impacted the current trend, so to say, where people are adopting newer technologies through open source, and you're not logged into a vendor, right? You are free to choose any of the open source mechanisms, and thereby the cost is significantly reduced. So just to conclude quickly, I think I have a couple of minutes here. So the development principles. So I'm assuming that there are many developers who are looking to towards this. I'm pretty sure everybody is pretty much aware of what moving towards microservices architecture would mean. But just to give you a an approach of building this. So there are certain principles which we typically follow, right? Follow the microservices architectural approach, that is breaking down applications down to single function. So every microservices will just take one simple input, and then it should just give out output. Without you should not complicate a microservice with more than one function there. So right, and then you should not you should make it very independent, right? Allowing it to be incremental, automated, and continuous implementation should be possible without a downtime. So you don't have to. Ideally, in a cloud native world, there is no downtime, and then you rely on containers for maximum flexibility and scalability. I think we talked about this, and then of course adopt the agile methods, agile as well as DevOps practices. I think that should set us on our way towards moving to a completely cloud native application stack. All right. So I think that's what I had. We can probably quickly take some questions.
Yeah. So there is this question. Monolithic application could be deployed on Docker to improve its scalability and flexibility. Containers contain on it we could define as microservice type, not to mention any VMs. What's your view on it?
Yeah, I think if I understand the question properly, so let's say that you have a monolithic app and you want to move towards cloud native, and we don't have the time or the resources to spend in converting that monolithic application to to microservices and thereby to containers, right? So there are people who have done that. There are people who have packaged this monolithic app as a container, right? And then they have hosted it on Docker World. So it gives you certain advantages where it makes you it makes it portable, it makes it infrastructure agnostic and all. But in terms of scale, there'll still be a problem, because even if there is a small a function in that monolithic app which is requiring, let's say, a CPU, right? You'll have to scale the entire monolithic app into you'll have to replicate the whole thing again. You wouldn't, thereby you're not leveraging the benefits offered by Kubernetes in terms of cost saving, in terms of resource saving. So yeah, that is the transition. That is how the big large enterprises are transitioning towards fully containerized environment. It is being done, but it wouldn't be able to leverage all of the feature sets that a true cloud native app would provide. I hope that answers the question.
Right. There's another question, saying by Lokesh again. He says, I'm baffled by your speech on self-healing properties of microservices. How will it self-heal?
Okay, so I think if you read about a Kubernetes architecture, so when Kubernetes deploys a pod, right? So Kubernetes doesn't deploy a container; it deploys a pod. Pod is an abstraction layer on top of Kubernetes. So whenever there is a pod, so Kubernetes knows where it has deployed that pod, right? Let's say there is a concept of master VMs, and then there are a concept of worker nodes. So the control plane of Kubernetes runs on master nodes, and it goes ahead and deploys this pod on a worker node, and it continuously monitors that pod for availability. It does let's say it does a heartbeat to check whether this pod is alive or not. So as soon as it finds that pod is dead, it provisions it again, right? So whenever let's say there's so when you want to deploy a pod, typically you write a YAML file, right? Let's call it a deployment.yaml file. So in that deployment.yaml file, you are specifying the replication count. So you say that my replication count is let's say 1. That means Kubernetes is bound to ensure that there is always one copy of your application available. And that is how it continuously keeps monitoring, and then it self heals. And the replication count could be 1, 2, 3, right? And there's a min and max it can scale to. Whenever if you say I need min 3 resources, it ensures that those 3 resources are always up.
Right. I don't see more questions now. I think everybody's hungry. Maybe the lunchtime coming in. Yeah. So thank you very much for your time, Pramod. It was a very insightful session. Looking forward to more such interactions with you.
Sure.
Thank you.
Thank you.
Thank you.